11.4 compound events. I can find the probability of compound events.
Analyst, thank you. Now, you guys, we did compound events. We actually didn't get to finding the probability until that very last problem. Did you guys realize that?
Yeah.
When I started asking about the and or the or on the fish and the pasta and all that?
Yeah.
Because you guys know how to find probability. In order to find probability of compound events, you actually have to know what the events are, right?
Yes.
So, interestingly enough, this whole lesson, we didn't really even accomplish the I can statement until the very end, and it took us like an hour to get there. So I'm up here. So everybody, you know that compound means what?
More than one.
Okay, that's what's frustrating to me right now. Eyes are up here. I asked a question. I want an answer. And I even said everyone. Everyone, you know that compound means what?
More than one.
That one's much better. Sample space is the second time we've had this word. You name everything in a sample space. A tree diagram. This is what we're learning to make right now. A tree diagram shows what, everybody? It shows the sample space. And then the fundamental counting principle really has a formula. The formula would be m times n, but you got to realize that m is just a variable. I'm going to slide up here. M is a variable that talks about total outcomes of one event, and n, so that's m, and then n is a variable that talks about total outcomes of another event. If I have a third event, would we multiply that third event by the m and the n? Yes or no?
Yes.
Again, I need eyes up here. So number 5 and number 6 were quick recaps. It never stops. Number 5 and number 6 were quick recaps. 5, FCP, outcomes of each event multiplied together. So if I have, let's say I have 4 events. I would take my first event, oops, ignore that. My first event, ignore that. My first event times my second event times my third event times my fourth event, right?
Yes.
And that would give me all of the events together. Yes, no?
Yes.
And then the tree diagram would actually show them all. We flipped a quarter 3 times to start. This is where most of you were confused to start. We flipped a quarter 3 times, and I asked you, what is the FCP? If you flip a quarter the first time, how many outcomes are there?
2.
If you flip a quarter a second time, how many outcomes are there?
2.
If you flip a quarter a third time, how many outcomes are there?
2.
So what is the FCP total?
8.
8. Okay, but if I wanted you to list all of them specifically by name, you would have to make a tree diagram. So again, you said if you flip a coin the first time, you get how many outcomes? 2. What are they? Heads and tails. Now, if you flip a quarter a second time, how many outcomes do you get? 4. No, you do not get 4. If you flip a coin the second time, how many outcomes do you get?
2.
2. The problem is, or not the problem, but what you need to do is you need to realize that if you got a head, your 2 outcomes can be attached to either a head or they can be attached to a tail. Now, if you flip a coin the third time, how many outcomes are there? 2. But the problem is that if you flipped a head and a head, you could get a head or a tail. That's different than if you flipped a head and a tail, in which you would get the head and the tail, and so on and so forth, right?
Yes.
So you have to list them all out, and then we even went a step further and we said what they all are. Does all of my named outcomes match my fundamental counting principle?
Yes.
Yes. Which is kind of what our cheat sheet said. Cameron said if I slide up here, the ends of a tree diagram total the FCP. We're going to count again. You guys ready to count?
Yes.
Okay, so let's go to our tree diagram. I had a really hard time with this today. Let's count the ends of our tree diagram. What's this?
1.
Everybody.
1.
What's this?
2.
Everybody.
3. 4. 5. 6. 7. 8.
And what's our FCP?
8.
Spinner, number 8, same idea. Spin 1, you could get a 1, 2, 3, or 4. Spin 2, you would get a 1, 2, 3, or 4, and you attach it to each of your first spins. And then this is the big one. Here's Rowan's restaurant. He's our head chef. 2 appetizer choices, 3 main dish choices, 2 dessert choices. All together, because you have 2 appetizers, 3 main dishes, and 2 desserts, how many total possible outcomes, you guys?
12.
What are they? Well, there they all are, right? We started with nachos. We did our main dishes. We did our desserts. If we started with cheese sticks, then we have to do our main dishes again and do our desserts. All of these, as Cameron said again, are going to match up to your FCP, right?
Yes.
Well, and then the questions I have for you down here. What's the probability of ordering a fish? You just use your tree diagram and count. How many times is fish used in your combinations? We said it was 4 out of the 12 combinations. Fish or cake. Is there a difference between the word or and and?
Yes.
Or means it could be one or the other. And means it has to be
Both.